Finally, we get to discuss part 2 of the Fundamental Theorem of Calculus. Not to make part 1 of the Fundamental Theorem of Calculus feel bad, but part 2 is really the one that you want. It's really the more useful of the two parts. And there's a big part of me that wonders why we wait so long to tell you about it. So anyway, here's what we've told you about this integral so far. We've told you that this integral from 4 to 12 of 1 over x squared dx represents the area between this graph and the x-axis and between the x values 4 and 12. If I was going to draw you a sketch of what that looks like, we would sketch 1 over x squared and look at the x values between 4 and 12, and this integral represents that area that I just shaded in there. Well, what the Fundamental Theorem of Calculus part 2 tells us is that we can find that area under that curve using antiderivatives. The integral from a to b of f of x dx is the antiderivative of this function evaluated at b minus the antiderivative of this function evaluated at a. So enough talk, let's do this problem. If we want to integrate 1 over x squared, it is helpful to rewrite that as x to the negative 2 power. And then we can recall this power rule for integrals and antiderivatives that says if we want to take the integral of a polynomial, or x to any power, we can raise that power by 1 and then divide by that same power at a constant. So let's do that. We're going to take the integral of x to the negative 2 by adding 1 to that power. That makes the power a negative 1, and we're going to divide by that negative 1. Now we just integrated this function, so we're going to get rid of this integral sign because we did it, but we don't want to forget about the fact that we need to do something with this 12 and this 4. So what we do is we draw this little vertical line over here, and we write 4 and 12 on that line, and this reminds us of what our upper and lower limits are. And I'm just going to do a quick step of simplification before explaining the rest of the problem. Okay, now we get to use this Fundamental Theorem of Calculus, part 2, which says that this integral we're trying to find is this antiderivative that we just found, but evaluated at 12, and then subtract the antiderivative evaluated at 4. What that's going to look like is we're going to take this 12, this upper limit, and we're going to plug that in for x, right here into our antiderivative. Then we're going to subtract, and we're going to plug our lower limit of integration in for x here into our antiderivative. And then our last step is just a little bit of algebra. This is negative 1/12 plus 3/12. We get 2/12 or 1/6. And 1/6 is the area underneath this curve that we were given between the x values 4 and 12. And that is it for that problem. And a common question, and a very good question, is why didn't we put our plus c on this antiderivative when we took it here earlier? And the answer is, well, we could have. If we put a plus c there, it doesn't matter what that c is. We would have gotten a plus c on this term right here, and we would have gotten a plus c on this term right here. And what you'll notice is that that plus c minus that plus c would cancel regardless of what c is. So typically when we're integrating, and this integral has limits on it, that's called a definite integral, we just don't worry about these plus c's. So we can take them off, and we can call that problem good, and we can go to the next one and get a little bit more practice.